Hi, good afternoon, everyone. This is Kamal Misra. Thank you so much. I welcome you to this webinar session. So what I'm planning to cover in the next few minutes is a very interesting topic around, we talk about data day in and day out these days, and how are we moving from data to artificial intelligence. So we'll talk about that. And then we will touch upon on some of the trends the world is moving ahead. We'll focus a bit of predictive analytics and what it is, what's the core, how are we looking at different methodologies as part of predictive analytics. And I'll try to cover a couple of use cases from my experiences, how predictive analytics has helped created that impact to the business. And then, of course, I'll summarize some of the value and impact that I have. And last but not the least, I'll also touch base on some of the critical skills that we would need, in my opinion, as part of successful data science, machine learning, and predictive analytics journey to move ahead with. Right. So that's where we kind of summarize the entire stuff in the next 40 minutes. But to start with the data to artificial intelligence, right? So let us focus on a bit of motivation factor, right? Why are we talking about data? Why are we talking about artificial intelligence? What is the definition of artificial intelligence, right? I mean, if you look at Wiki, the way it says the term artificial intelligence is applied when a machine mimics cognitive functions that humans associate with other human minds, such as learning and problem solving, right? And another definition you can also look at from the wiki says, in computer science, AI research is defined as a study of intelligent agents, any device that perceives its environment and takes actions that maximize its chance of success at some goal, right? So we are talking about intelligent agents, we are talking about cognitive functions, and we are talking about how we can learn and problem solve like the way human minds does. And that's kind of artificial intelligence. That's how we are moving ahead with, right? And then I would like to think you, when you look at artificial intelligence, from how the entire world is moving across, right? How the entire world is moving from the data world to kind of artificial intelligence, that side of it. And when we look at that, I'm talking about reporting to storyboarding, right? What we have seen is, and all of us know, we have something like descriptive, then we move on to diagnostic, right? In the sense that this is something kind of a hindsight. We ask questions, what happened? That's kind of a descriptive scenarios. And why did it happen? That is more diagnostic. You're diagnosing a problem and trying to see what is the cause, what is the root cause of this to make it happen. And then we are moving to an insight in the sense that what will happen, right? If this is what has happened in the past few days, months, years in the past, based on that trend, how is it going to happen in future? What will happen in future? That's more of a predictive. And of course, then the prescriptive one, where we talk about how can we make it happen? You know, we define, we get to know the trends, and we will say how can we make it happen, which is kind of a foresight. So this is linking up from the hindsight to insight to foresight. That's where I feel it's moving from a reporting to storyboarding kind of a concept, and that's where the entire data journey is evolving in the entire data jungle. If you look at, you know, data is moving on to the artificial intelligence platform. When I look at the flow, obviously we start everything with business objectives, right? That is a need, that is a impact that we need to create, and impact is of course defined by the need. You would have a requirement, you would have an objective, you would have a goal. We talked about some goal in the definition that Wiki has mentioned, right? A couple of slides back. And then if we have the business objectives, then we're talking about data infrastructure. You would have a platform, you would have some infrastructure to achieve certain things. You can store the data, you can collect the data, and then you do on top of that. What we're talking about is three things. We're talking about analytics, we're talking about machine learning, and then we're talking about artificial intelligence. Now, the way when we look at it from a artificial intelligence and a predictive analytics standpoint, or a predictive standpoint, if I were to look at it, if you compare with the previous slide, right, we talked about hindsight, insight, and foresight. Then we're talking about collecting the data, which is kind of a data collection, then cleaning the data, right? And then moving on to find some patterns, identifying patterns, and then make predictions out of it. So that's where the predictive part comes into picture, where it provides value. But it's not pretty simple and straightforward. There's a lot of analysis needed, a lot of understanding of data needed, a lot of domain knowledge is required in order for us to understand what is the business goal, what is that we are trying to solve, and what are the questions that we are supposed to ask in order to reach to that goal or problem, right? And that's where some of the techniques, some of the algorithms, the technology is constantly evolving in such a way that it's helping us to achieve and accomplish some of these predictive goals that we're trying to achieve, right? Now, moving on, what I look at the process is, if you all look at in this scenario, right, a bit of more motivation to why we're talking about this is, you have, all of us know the structured data, the unstructured data, semi-structured data, of course, and a lot of those data are getting generated, right? And we also understand that in the current scenario, there are enormous amount of capabilities where we can store these data in databases, in servers, whether you use different type of technologies, different type of big data technologies, which is enabling us to store these data, right? So there is a data generation which is happening, data collection which is happening, and data storage which is happening. And it's allowing us to, the technology is helping us to keep that in a one place so that we can consolidate, we can process it, right? So when we talk about process, then the data processing comes into picture, right? And data processing is, again, where we talk about different mechanisms, different algorithms, be it machine learning, be it artificial intelligence, using various, your CPUs, GPUs, all the compute power to create actionable insights. And that's where you have your predictive signals or goals, or the results or outputs generated. And then, of course, you have mechanisms to see whether we are predicting it right, or what is the close to the accuracy that we're talking about, so on and so forth. So this data processing and actionable insights, this piece of task and activities is essentially the artificial intelligence side of it, where you have the data science, you have the machine learning, you have, and there's a lot of other stuff that I'm not talking about. Let's talk about deep learning. So a lot of terminology, right? I mean, all this is part of the same, different varieties and flavors. But on the left-hand side, you have the data generation and data storage, right? So that's the process that we are looking at. Now, moving on to what exactly is the opportunity and how is the disruption happening, right? So when we look at from a broad sense, why are we talking about all this? And there are a few parameters comes into picture, right? One is, of course, innovation. We are talking about a business strategy, a business goal, business imperative, and we are trying to innovate to solve a problem. Because at the end of the day, we are trying to solve business problems with the help of the technologies, right? And analytics is playing a critical role, where we are defining an approach, we are defining a methodology, and we are leveraging it, with the help of certain technologies that enable analytics, right? And if you look at the ecosystem, of course, there is a holistic view. We talk about, whether it's Mac or whatever you call it, right? Social, analytics, mobile, cloud, a lot of those combination of that ecosystem in place. And you also need to look at the KPIs, the key process indicators. The right KPIs or processes is essentially a culmination from right amount of data that we're talking about. And the point that we can get to the right data if we understand the business objectives well, and we understand what needs to be done and why it needs to be done, right? And then, of course, there's a bit of automation involved, because the way the entire analytics platform is shaping up is, of course, we are automating a lot of aspects, everything. And with the way that we are talking about machine learning or artificial intelligence, for that matter, there's a lot of automation involved, where we're trying to mimic, you talk about the chat bots, you talk about different NLP programs, the natural language processing programs, where we are seeing all this, right? If you go and look at each and every industry, for that matter, is trying to make sure how they can increase the customer experience, how they can increase their digital footprint, and in a process they want to automate this entire process, right? In order to better understand the customer more well. And all this is very important if we have the mindset, because mindset is essentially something which is related to change, right? And when we talk about this, we know in our life that change is constant. And then when you look at last couple of decades, the way the entire technological evolution is happening, we are looking at the way the entire thing, the data platform is changing and shifting gears, moving on to a different platform, moving on to a different technology segment altogether. But again, the focus and mindset has to change to cope up with it, to equip. We understand, how it is doing and why it is doing, right? And then it'll have the added impact. So essentially, what we're talking about is, analytics also help us enable to kind of interrogate right data. That's pretty much key, which is for solving any business problems, right? So my kind of favorite slide, where we've been talking about the change, the essential process. So all of you, some of you have been familiar with this Star Trek and Mr. Spock, right? So change the essential process of all existence. That's kind of a bit of a motivation. This is what we feel to move on to the next step, right? All right. So I feel we have kind of gearing up. Why we're talking about this. Why is data, artificial intelligence, predictive analytics? Why is all important? How it is shaping up? But it's important to understand the trends in the market, right? So let me move on quickly and then talk about a little bit about the emerging trends, the way the world is shaping up, right? So if you look at this chart, this is, and you can Google it and find out in the internet, right? So 60 seconds, we're talking about 1 minute, and then things that happen on internet every hour. You manage every second, every minute, every hour. I mean, and then you extrapolate it accordingly. So this is like humongous. And then every time we keep looking at it, right? I mean, when we were talking about 2013, 2014, we were told that whatever the amount of data generated till 2012 or 13 is just doubled in 2014 or 15. And again, it's quadrupled. So it's humongous. And one, of course, there's a lot of compute power. There is a scalability. There's a flexibility aspect in the technology which is helping us to achieve it. Of course, the cost factor is going down, so that you can process, you can compute, you can store, you can digest those data. And that is important, because unless until you have most of the data, how is it possible for you to analyze it in order to find a solution or an answer to the business problem or the question, right? That's very important. But this gives a magnitude of how the entire different gamut of areas data is stepping up and evolving, right? Now, coming to the next, this is very, very critical when we talk about top 10 strategic technology trends for 2018, and this is something which is courtesy Gartner research. If you look at that, they kind of call it as intelligent digital mesh, right? And then you have almost 10 items that we are talking about, and these are extremely critical, right? One, we talk about kind of an AI foundation, right? Um, which is nothing but creating systems that learn, adapt, and potentially act autonomously into a battleground for technology through at least 2020 to 2025, right? And the ability to use artificial intelligence to enhance the decision making, to reinvent our business models, ecosystems, to remake the customer experience will drive the entire payoff for digital initiatives through the next 5 to 10 years. So that's very, very critical. And some of the data points, if you look at the widespread adoption of artificial intelligence, if you take about that and how it is impacting decision making applications, according to Gartner, I think there are 59% of organizations are still building their enterprise artificial intelligence strategies at this moment as we speak, and while the remaining 41% have already met the pledge. So look at the way the fast pace in which everyone is setting up, because we understand the value of it, the impact of it, and what it can create us to achieve it, right? Then some of the other key points, right? One, if you look at something like intelligent apps and analytics. So again, when we talk about augmented analytics, right? Somebody said clearly that augmented analytics is a particularly strategic growing area which uses machine learning to automate our data preparation, insight discovery, and insight sharing for a broad range of business users or operational workers and the citizen data scientists, right? That's what they say. So this is stepping up into extremely complex and useful scenarios. Most of you, I believe, I'm sure you would have heard about the Internet of Things, IoT. Now we're talking about intelligent things, right? Intelligent things are physical things that go beyond the execution of your programming model to exploit AI to deliver advanced behaviors and interact more naturally with them, with the surroundings, with the people. You would have, if you take the example of Amazon's Alexa, right, or Apple's Siri, right, or IBM's Watson. A lot of these, and these are getting a reality. I mean, of course, we talk about a lot of Google's different Google Glass, then the driverless cars. A lot of these things are slowly getting into action. It's not that they're still in research or evolution. And then as we speak, there's a lot of research still going on, something called as quantum computing. So in the field of the computing, and then how we can leverage where there is a scale, and we can leverage this technology to solve problems which are at scale. So that's the intent, that's the objective everyone is heading towards, right? Conversational platform, I would take that, where an example, if I were to give, this is something again similar, kind of a chatbot. This is fairly used in majority of the cases, I would say. For example, all of you in India, if you go to some of the banking sites, right, you would have your bank accounts, and you start looking into most of the banking organizations have some of their chatbots already created. They'll say the moment you log in, they'll say some of the questions that they will ask, are you looking for a specific product or service? And then, that's again very specific based on the way they are building the knowledge base, because they know what customers want, number one. Number two, they know to some extent what are their past portfolio. And then number three, how to leverage that, build a set of questions, build a pool of questions, and have the answers ready for them, so that the moment they ask certain question, and they would have this conversational platform to give an answer as close as possible, right? So a lot of, and this is again the you would have seen some of the sound boxes or something from Amazon's Alexa and other stuff, where these are all conversational platforms being used rigorously, right? Um, the challenge that conversational platforms face is that users must communicate in a very structured way, and this is often a very frustrating experience, because like you can't you expect everything to be a fairly green field, or very ideal scenarios. That doesn't happen, right? So for example, if we talk about driverless cars, that probably may happen in a very very ideal scenario, but what happens in a situation like Indian roads, right? So all of us know, but at the same point of time, the attempt with the evolution of the technology, the trends, the way entire data is being used is significant and terrific, in the sense that it's shaping for a very very bright future, right? Some of the other areas, of course, I'll not go into, because there are too much areas around this. You can always read, you can Google through, you can go to Gartner, and then this is really very interesting thing to know and understand how it impacts to the area that we deal with, right? So let me go to the next chart, and then this is where I would like to just look at some of the numbers, where you look at the globalization, and we speak about some of these data explosion, right? 50x growth by 2020, 90% of the data created within the last 2 years. How the rise of mobility, cloud, all these things are impacting. And then if you look at some of the trends to focus, of course, the digital experience, the personalization is extremely critical. We know this, we understand this in every industry, be it retail, healthcare, BFSI, or every industry, but it's very, very important to address those problems that we face from our customer, right? That itself gives us a enormous edge compared to our competitors when we do that, right? And of course we are solving problems based on that. And you have then of course mobility. Then we talked about IoT, of course, you have Internet of Things, and we're talking about intelligent things and all that, right? And of course big data and predictive analytics, right? So just to give you a flavor, these are some of the analysts and then some of the sources that been captured and still evolving. This is again more and more numbers, probably still dated, and then you'll see larger numbers going forward. So let me switch on to, so that being said, kind of looking into the overall trends. That being said, kind of moving on to what are we talking about predictive analytics at the core, right? I think from a methodology standpoint, it's very important to understand this. And if some of you are aware of it, great. If you're not, it's probably you can take a look at it and then see the CRISP DM methodology, right, which we talk about for the cross industry this platform, right, for this entire data mining, right? We're talking about this cross industry standard process for the data mining. And then what we're talking about is a very iterative process, number one. Number two, starting from your business understanding, defining the business objectives, get the business clarity, and then move on to data understanding. Now, data understanding, when you're in that step two, you can still go back and forth to the business understanding and come back. And then you move on to the third step, which is data preparation. Now, before you move on to data preparation and data understanding, there's a lot of exploratory data analysis that needs to be done. Visualization would help you find and uncover some of the insights that is needed. And of course, you move on to data preparation, modeling, evaluation, and deployment for the matter. So this is a typical life cycle, typical process and methodology followed for most of the predictive and analytics programs. and that gives an edge to understand and apply our entire task in a similar fashion. This is very important. When we talk about the data collection, right? So where should you be spending time? Ideally, if you look at the data collection, exploratory data analysis, you perform some data merging, some transformations, wrangling, model creation. Ideally, those are the 80%, and then of course the decision making and report preparation and assessment are 20%, right? But the way it's shaping up in the future is we want to automate, we want to have this entire data collection till model creation process so streamlined that you spend 20% there, so that you leverage the power of analytics and predictive analytics and use your time for decision making and assessment more effectively. That should be the 80%. That's a ideal scenario. World is moving on. And we also need there is a tremendous need for structured analysis, right? We talk about tactical views, we talk about strategic views here, right? And if you look at this chart, it talks about some of the examples and use of streamlined analytical solutions to manage the time needs. So one, we of course follow the methodology that is defined. We follow that particular step, iterative step through that protocol, and then we streamline the entire solutions to manage our needs. And it's also important, we are talking about from the beginning of this, that it's not easy to get the need right, to get the drive for the right data, right? That is very important, because then only we are going to answer to a question effectively. So moving on, I'll try to talk about quickly on a use case with that mindset. A bit of motivation. We talked about trends. We talked about predictive analytics methodologies, what it means at the core, and I want to talk about a couple of use cases. So the first one is around a device level failure prediction. And this is a very interesting scenario where the business objective for us was to predict failure of a device or machine and then have that availability. So if there are 10 devices or 10 machines, then the business impact is more based on the availability. And availability, of course, impacts what? One, of course, is the revenue, and two, customer satisfaction directly. Right? So these two are the direct impact there. Objective, the way we looked at the solution is, and the problem is to increase the availability, is what I've been talking about, by effectively doing our service repair or servicing the components of the devices proactively before they fail. So for example, a component is going to fail in the next month. Now, if you know and predict it correctly, then you would send your field engineers or staff to go and fix that problem upfront. So one, you are predicting it right, and then you are having the right machine replaced, or the part replaced, or the component replaced before time, so that the availability to the customer is absolutely seamless. There is no outage. And number two, you are also doing it in specific manner. You know upfront which ones to do, which ones not to do. Now, this is essentially, if you look at this machine level failure prediction, this is there is a constant shift that is happening. It's a paradigm nature, the way the shift is happening. Earlier, it was more of a preventive scenario. Now it's getting into more predictive scenario. I mean, if you look at those, it's like more reactive earlier. Now it's more proactive, right? Earlier, it used to be based on automation, based on high-level trends. Now, as part of this solution that we have provided, is more based on your statistical analysis, your machine learning, your predictive analytics data and behavior. And these are all based on your past historical data. We used to have the features or the parameters for the past X number of months. And then based on that, we were able to build and create a model and feature engineer some of the parameters that we did to be able to accurately predict not only at the device but at the component level. So we know if there are the 5 parts, part 1, part 2, part 3, part 4, part 5, these are the part 4 which is going to fail next month. So we just need to take action. We just need to go and fix it, right? So that's a shift which is going on. Now there are a few things as part of this use case. What we looked into, and I feel this is very significant, is at a component level prediction. Because if there are 10 devices and then you'll say, okay, the 7th device is going to fail in December, that is, yes, that's one information. But currently, the world is moving into much more. And then the ask is, okay, if the 7th device is going to fail out of the 10, now in that device, there are 5 components. Which component in that 7 device is going to fail? Because if I know that, that's a greater insight. So one, we ingest the data for all the components. So component level, device level information is available. We have generated features and performed, as I said, feature engineering. And this is again depending on some of the codes or the logs generated in the past. And based on that, the service engineers is going to create, or the user is going to create the ticket, right? And so we have in the past, you have the data which you are using as feature, and then you are predicting in the future which one is going to fail based on that feature. And the model that we have created is trained based on the past historical data features, and we've validated it with the test set. The key aspect that we have done there is looked at. There are 2 ways you can do it. One, you can go ahead with a 70% of your train data and 30% of your test or validation data, so that you pick 70% of this 100 set of records randomly, and then you test your model with that. You create your model with that and test your model with the remaining 30% of the test data, right? That's one way to look at it. Second approach is also to look at is that you define it based on time window. So for example, I would like to train my model based on last 1 year, but till just before last 2 months. Let's say, for example, till August or September. Now, September, October data or October, November data is what I'm going to test it with that window. And then I'm going to predict for the next month, December or so, right? So that's what we have done as part of this. And then predicting failures, it's kind of a binary classification. Obviously, it will create a yes or no, a true or false, 0 or 1 kind of a classification, whether it will fail or not, right? The benefits that we had as part of this is improved operating efficiency due to the way we are able to predict the unexpected equipment that may break down in future. That's one. And then second, of course, prediction of the failures that grants the opportunity to plan the downtime for maintenance. Because you would say, okay, if this is going to fail this, then there are 10 locations in which it's going to fail, and then we are going to plan for those downtime maybe next Sunday or next Saturday or something like that, right? It's also the inventory cost is decreased because you know upfront for the next 1 month, these are the 3 or 4 parts for these devices that are going to fail, and I'm going to keep inventory of those devices because those will be replaced when the service staff or the engineer staff goes and replaces that, right? So, and then when we move on to the prediction accuracy and performance that we did, right, and this is where we used precision and recall. This is a statistical phenomenon. You can also use specificity and sensitivity to understand the accuracy of your prediction that you have done. And we also, let's say, for example, I have predicted for 100 devices for the next month, right? And there are some probabilities. You'll get the probabilities between 0 to 1, right? We have also used something like Yoden-Jet statistic, which is J is your specificity plus sensitivity minus 1. And this is something will define your optimal cutoff point. That's an approach where If let's say, for example, probability of cutoff point is zero point 0.4, so you'll take only those which are above 0.4 and then predict those. Right? So that's a statistical method of improving your accuracy, since you are doing it more from that perspective. So then moving on to, so that was one of the use case scenario. Second one, if you look at something like a banking scenario where there are different interaction points, different channels. You have call center, branch, ATM. The integrated channels are a lot. Point of sale, a lot of things you have, and then you want to get a visibility across system, which is always challenging because there has to be a collaboration of data, and then you will start looking into a lot of these things, the diverse ID systems, the way the transactions happening. If there is a transaction failure, is there a transaction failure or not? Is it going to happen in the next few days or minutes or whatever? How many transactions are in real time right now? How many are abandoned? And a lot of these information, right, in real time or near real time, right? So that was one of the challenging case. And two things. One, you want to have your questions based on different personas or different stakeholders, right? So, for example, you have a product head, and just say somebody with a job role of product head, and you would have different questions. You would be more interested for your product design, risk, profitability, and so on and so forth. Now, if you look at a relationship manager for that matter, and then that will have different, because for relationship manager persona or stakeholder, the area of reason or responsibility is different. Presenting, how to present a relationship, develop a relationship, and retain relationship. So that way, your your entire focus point is different. But having looked at this, what we did is we kind of our main objective was to predict customer attrition in this scenario, and to identify the loyalty, the loyal customers from the customer pool. So we did some dashboards, metrics, outcomes in terms of a new account by product or account attrition by product. A lot of these exploratory analysis, and customer profitability by age. A lot of these have been data has been wrangled, moved for all this information, and then we had a smart model approach to predict the attrition. Now, this is where we looked into, you would see something like a fishbone architecture, customer attrition. If that's happening, why it is happening? Is it related to their product holding? Is it related to delinquency of their data? Is it related to the demographics? Capture all those as features. Capture all those as your parameters, which you can use for your predictive analytics, and then come up with a score, and then define a threshold where you can say, okay, anything which is more than 68 captures the customers with highest tendency to attract. So I should look into those customers, right? And then this is again derived based on last X months of data, historical data window, and then a lot of those things. Different data being kind of captured, consolidated, and then So this is one. I spoke about a device level prediction, failure prediction, and second, customer attrition, how you can predict that and capture it. Right. So moving on to kind of summarize the value and impact, right? I mean, this is my favorite slide where I look at and say, not everything that counts can be counted, and not everything that can be counted counts. This is the famous Albert Einstein lines that I love to look at. And if you look at the impact that is happening is primarily in the area of data-driven decision making, right? We're talking about the key drivers, and then different areas, whether we talk about customers' user experience or operational aspects or strategic aspects. It impacts top line, it impacts performance, and these are all some of the data related to some of the survey that NASCOM does. So this is just an example. You can look at IDC, you can look at Forrester, you can look at other analysts, you can look at a lot of other organizations doing this data, and then you would find very similar trend in terms of how the decision-making process is faster. That's one aspect, and second, of course, accurate, right? if you're able to predict something accurately, if your accuracy is more, then that's where it's more effective, right? And everything boils down to the cost, and everything are related, right? Post that, you improve your ROI, you kind of control your cost, and a lot of those aspects that come into picture, right? Um, of course, there is a bit of adoption. If you look at the industry verticals, adoption rate in BFSI and telecom that you see has been larger, but I think retail also has gained momentum a lot. Manufacturing also has been happening. Healthcare has been, it used to be low earlier, but it's picking up, and then a lot of different fields, and it's being used and leveraged. That's the great part of it, with the compute power, with the analytics framework, with the actual ground level solutions. We are able to solve problems and have answers for them. Right. So then, last but not the least, I would like to quickly touch upon another element of critical skills. Right. What is needed? Um, what is needed from a data science program perspective? Um, why are we talking about this? What skills are needed? So um, I'm sure all of you are familiar with the left hand of the diagram that you see. What's a data scientist? What's the critical skills? We're talking about hacking skills. We're talking about mathematics and statistics. We're talking about substantive expertise around different domain and other aspects, right? That's a combination where you see a data science professional being. But in my opinion, there are a lot of elements to it, and some of the six elements captured here is, one, of course, is very important, is the fact that uh, somebody has to be good in statistics and mathematics, and then of course you can acquire the machine learning, because it requires a lot of statistics and mathematics to be applied when we perform machine learning aspects of it. Second part is, again, learn to code well is nothing but your programming concepts, programming aspects. Whether we, and this is something is in our DNA, where we get all these concepts long back during our engineering days, or our 10 plus 2 days and all that stuff, where we start and acquire these aspects, right? And then third is understand to work with databases. That's also very important, because when we deal with data, and whether up to we talk about machine learning, deep learning, artificial intelligence, it's very important to understand entities, attributes, the data model. That's the heart of everything that we're dealing with. And of course, how to deal with RDBMS and different queries, because SQL queries are very, very important to drive this. And fourth is very critical, is around mastering the data munging and visualization aspect. Visualization is always an art, and it's a huge area altogether, where there's a lot of focus around what we derive out of the data, and then what we can project and see. Right? I mean, you can look at a lot of TED talks, TED forums, very famous Thomas Wrangling, to see some of the talks where it's very well articulated. There are a lot of tools in the market, like Tableau, like ClickView, and of course Watson, and a lot of other stuff where we can use and leverage and visualize, and of course D3JS and all that stuff. Data munging, data transformation, data cleaning is a very, very important activity, because when we talk about predictive analytics, when we talk about a lot of these things, it's going to be a huge amount of focus also lies with the quality of the data. So we spend a lot of time in handling a lot of these aspects, data quality checks, data validations, which is where the data wrangling, data munging skills is also needed in terms of how we want to play with that data. Number five, I would say the level up with big data, in the sense that we need to understand what's happening, because if the way the entire data deluge, the way it's shaping up, the way it's going fairly high, what are the technologies that can help me establish what I want to achieve, right? Whether it is analytics or advanced analytics, I need to have a computing power where I can keep the data, store the data, and then we'll be able to process on top of it, which is where a lot of the big data technologies come into picture, right? We're not going to that. That itself is an ocean. That's a different area altogether. And the sixth, more important aspect also is last but not the least, I would say very, very critical is around how to tell a good story. It's not easy, you know. And I'm sure all of you would appreciate the fact that, when you try to tell something in a correlated manner, in a linked manner, or a sequential manner, it's not that easy. I mean, there's a enormous amount of effort needs to be given in order to analyze it, in order to make sure we correlate, we understand, we project, we analyze the entire stuff well, and link and stitch that to tell it to a critical story or key story or whatever it makes sense for the business, right? Or the problem that we are trying to solve. So all of these, in my opinion, are very critical, very important, and you would realize that some way or the other, in majority of the cases, in a lot of scenarios, that you'll find it very, very encouraging, very, 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 very apt to be able to be able to look at those, right? Um, I thought I'll also take some 3-4 minutes to talk about some of these skills which may be relevant, and that's why this slide was there. So kind of summarizing now, we talked about kind of key takeaways out of this, right? So we're talking about the way the entire data journey is shaping up, the motivation around that. It's very important. Whatever we do, we get ourselves motivated, and then only the data journey will go. And then it's the way I mentioned, data to artificial intelligence is, it's in different steps, right? Where predictive analytics play a very, very critical role there. We talked about trends. We talked about the predictive analytics, how it creates impact in the business. We talked about the CRISP DM methodology. That's very, very critical, because that would be, you would use that every time, and most of you are practitioners. You'd be using it in most of the cases where you leverage those methodologies to derive and drive your entire program relating to predictive analytics. We talked about the failure prediction. We talked about the customer attrition prediction, and these are some of the very few use case scenarios. There are a bunch of such different areas that you can achieve. But the technologies, of course, is changing, and it's helping a lot for all of us. And of course, we talked about the core skills about it. So that's pretty much, I feel, the data and artificial intelligence, specifically predictive analytics, is kind of helping us bridging the gap, right? So that's where this that slide, the chart of bridging the gap between the two.